All right. Well, first, I'm going to be brief. Okay. This is a hard act to follow all day long. Tremendous speakers here. And first, I just want to congratulate Bruce on his retirement and his career. Obviously, you're an icon in the industry, and the entire contracting world and the design world owes you a tremendous debt of gratitude. So, thank you, sir. So, on topic here. We've heard a lot related to constructability and productivity, and that's I love seeing that in the association or the institute. The push for both of those two, they fall hand in hand, relying on one another. One relies on the other, and I wanted to take a little bit of time here to go through some examples of how a contracting method that we just became involved in an IPD project, an integrated project delivery, and how that type of contracting method really facilitates the constructability review, because you start from the very beginning when the job is basically just a concept. So do we have any IPD experience in the room? I know Baker's done quite a bit of that. Okay, Chris, yeah, I'm sure you have too as well. Anybody else? So, I mean, just in general, IPD is a type of delivery method where all the major players will come into, they're brought under contract early, very early, when the job is nothing but a conceptual design. And you're contracted and paid as a concrete contractor, the steel fabricator, steel erector, mechanical contractor, electrical contractor, general contractor, design firm, and owner all work from the very beginning of the design process all the way through to try to help develop the most constructible, most efficient, most optimal design, utilizing everybody's talent in the room. So I had a good example that just happened with us, and I'm going to try to go through it. I think you all will see where I'm coming from, if I can figure out how to operate this thing. Okay. So initial conceptual design. We're not seeing the whole picture here. Okay, yeah, there we go. All right, so the initial conceptual design, I'm not at liberty to discuss the project name or what the overall project is. This is only one portion of the job that I wanted to explain how the design evolved with everybody's input. So initially, we had about 9,000 linear feet of 2-foot thick wall, 36 feet tall, okay? Of that 9,000 feet, 3,000 was the wall, and the other 6,000 were buttresses at 15 feet on center, all the way around the wall. We estimated that was going to take 6 to 8 months to complete. There's the site, the actual building site, consisted of between 2 and 10 feet of overburdened soil and granite below that. And basically was a hill that had about a 60-foot variation in elevation from one side to the other. As all the contractors in the room are probably thinking the same thing that we were once we saw this, this is going to take way too long, and it's going to cost way too much, right, for anybody to want to pay for it. So we immediately, as a team, pulled together and started trying to seek solutions. And the stakeholders that were involved, obviously the whole job were stakeholders, but the ones that really played a critical role in making suggestions and brainstorming and trying to find a way to simplify this job to make it doable were the owner, general contractor, concrete contractor, the structural engineer, and the geotechnical engineer. So we started asking questions. What are we going? We had about 12 to 16 weeks to build this thing, and we were nowhere close to that with I mean, maybe somebody can do it. We were having a hard time figuring out how to do that fast. So we're trying to figure out how to save time, what's it going to take to reduce cost. Going back to the drawing board, we're so early in the whole process that we asked, well, is the building actually in an optimal location? I mean, can we move it to try to make this easier? The wall height, 36 feet. I mean, does it have to be 36 feet? What's dictating that? Let's go back and ask questions about equipment and process and all that to figure out whether or not that 36-foot height is actually a necessary part of the project to deliver a building that the owner can use. The wall height, you know, if we can change the height from floor to floor, we can reduce the wall height, wall thickness, you know, that's money, concrete material, foundation size. We just started throwing a bunch of questions out there and trying to figure out anything that we could do to try to come up with a more cost-effective and quicker design to build. So seeking solutions, we found that it was feasible to move the building, and it was not in the optimal location on the site. We were able to shift the building and twist it in order to daylight out one end of the building, which reduced the need for a lot of the wall. Okay, we looked into the equipment clearance, and there were a lot of boxes checked, and nobody really knew what they needed. They just knew that this height was going to cover it. When we really started drilling into that, found out that height wasn't really needed. So we changed the floor-to-floor height to 26 feet from 36 feet. You know, so all that reduced the amount of soil pressure on the wall, which was going to help our situation, but it didn't quite give us everything we needed to reduce the overturning and sliding moments for the wall. So anyway, we looked at lightweight backfill options. And I should give credit to the people who came up with these solutions. The general contractor is interested in finding out whether or not we can move the building. The general contractor also looked into the equipment clearance required. The geotechnical and structural engineers and concrete contractor were all intimately involved in figuring out how we can reduce the amount of soil pressure on that wall. And so we looked into a couple of different lightweight backfill options. Let's see. So brainstorm, like I told you, we reoriented the building. We put an earth retention system in place and soil nailed the wall just outside of the building, about 5 feet outside of the footing. We soil nailed that wall, and we were considering either using styrofoam block, the big geo blocks, or using lightweight cellular concrete. The general contractor actually came to me and asked me about the lightweight cellular concrete, and it was shortly after I'd been to the ACI convention and sat through that committee. And so I said, yeah, I know a little bit about it. I know more than I did 2 or 3 weeks ago. So anyway, we looked into potentially designing a keyway to protect for sliding. Problem there is we're going to have to trench blast that much rock in order to put that keyway in. We ended up settling on the lightweight, the cellular concrete material just because, well, for a couple of reasons. The soil nail wall was going to be inconsistent in its location because of the fact that we had to blast granite and there's soil nailed into that. And you can't soil nail into a blasted rock that's loose. And so we had to we knew that it was going to be unreliable in location. We were going to end up with something that it'd just be easier to do the backfill with the lightweight cellular concrete. Plus, it's excavatable. You know, a building this size are going to be utilities are going to need to come in later, and I didn't want it to look like the coffee cup factory exploded down the street with all the styrofoam. So the decisions we made, like I said, we reoriented the building. The floor-to-floor height was reduced. We ended up shotcreting, or ended up evaluating between traditional form and pour versus shotcrete. That was another good option, but the soil nail wall being unreliable for its location made that a more difficult solution, or a higher risk solution. So we ended up with the traditional form and pour and using the cellular concrete for the backfill. And just to kind of give you, this is what this thing looked like through different design iterations. So we started off with the foundation. It was 10,000 yards and 3,000 linear feet, and then all those buttresses at 15 feet on center. The wall itself is 16,000 cubic yards, and 207 of those buttress walls. That was reduced down to a second design. We took all the buttresses out and shrank the wall. And then eventually we were able to thin the wall. It's all straight wall and just has corners. Much faster. The construction time reduced down to about probably a 14-week period to get that done now. So anyway, very difficult to get something like this done in a traditional design bid build scenario. It's about, it's pretty much impossible unless you've got a lot of time. And unfortunately, most of the owners we work for don't have a lot of time.